In modern Windows 11, Microsoft added an interesting new feature, where if you were to open up Notepad, that native, installed by default, and built-in text editor, you actually have different tabs, where you can open and work with multiple files, interact, work with them, and save them. But the interesting thing is, if you close out of Notepad and then were to reopen it, you still have all of those saved and available, ready for you to resume work just where you left off. Here I have two different tabs open, something for some Screen Connect work that I was doing on this virtual machine, and drivers, etc. hosts over in the C Windows System 32 directory. Now, again, as you saw, I could just reopen anytime I wanted to that Notepad instance, and if I wanted to start a new tab, I could write anything I want. A little cheesy, please subscribe, but if I, just navigate around, I could close out of this and reopen Notepad once again to see that that tab is still intact. Now, we might have a wondering question: how does that happen? How does it get saved, or does Notepad cache anything that's open in a buffer, whether it's saved or not? Well, I'll answer that question for you pretty quick. Yes, it is saved, and this is a really interesting artifact that could be used for blue teamers, defenders, folks doing digital forensics and incident response to see what might have been open in that text editor, or even red teamers, penetration testers, and ethical hackers wondering if there's any juicy details that just happen to be left in that native default text editor. Let me hop back to my Windows 11 virtual machine and I'll open up the Windows File Explorer. I'll navigate over into the address bar and let me use an environment variable here, just wrapped in two %signs. I want to go to app data, but I actually want to prefix this and go to our local app data. You might know, there are a couple different folders inside of your user account's application data. There's one for local, local low, and roaming, but local is really where we want to dig into, and there is one directory here called packages. Now, this has a couple interesting things for native Windows applications or other things you just might have installed. Of course, we might be able to drill down and find a Microsoft folder for Notepad. Here it is, Microsoft Windows Notepad, with an odd looking, suffix at the end there. But if I dig into this, we can find a couple other interesting folders, and there might be some juicy details there. Now, I want to bring us down this rabbit hole. If I move into the local state folder, there is one called Tab State. Also a little bit curious, what might be in Windows State? These are probably worth digging into just as an aside, but look, I feel like I just got nerd sniped while I'm recording to go want to explore something new. But Tab State is interesting because it looks like there are a whole lot of different files in here, all defined as a GUID. You can see, some random hexadecimal in that pairing of numbers and the set of digits there. And these are .bin files. We see some end with a .0 or a .1 before the file extension .bin, but these are all things that are artifacts, remnants of that cached Notepad buffer information. Now, let me try to open one of these files up. It's odd to me that I have this .0 or .1 suffix before the file extension, but I think I'll go for the 639744 whatever GUID, and I'll double click on this, and it will need a program chosen to actually open that file. The .bin file extension, Windows doesn't know what to do with naturally. So I'll open that with Sublime Text, my text editor of choice, and I open this up, and it is a binary file, right? Hence the name. So Sublime Text will just show us the hexadecimal representation of all the contents within that file. On its own, this isn't all that helpful or useful or interesting to us, but we might be able to dig a little bit further and see some oddities. If I actually minimize this, I'll go ahead and open up a command prompt, and I will use one of the tools that we could find inside of sysinternals, the sysinternal suite you can find online. Now, I have the sysinternal suite available for me from the root of my file system, C:\\, and I want to try and run simple strings. If we were on Linux, that would be a natural built-in, but on Windows, we will need to rely on sysinternals. So let me see if I can run strings on this file present here inside of that app data directory. So let me copy the path. I'll paste this in and I'll just hit enter. Can I? Oh, sure. Yeah, I'll accept the EULA. That's fine. Ooh, this returns the exact same data that we saw just opening that file in Notepad. Actually, looking into it, it even includes the file name or the whole path to that file that was saved. There is some oddball data in here, a C exclamation point closing parentheses, whatever, but we could genuinely see the plain text, the raw data, the values that were present inside of that file, and we get to know the file. I could do this for just about any of those GUID bin files that we'd like. What else did we see in there? There was a 0FF and a C2A. Let's see what that 0FF one is. That is our please subscribe. Nice. Now, naturally, if I were to go take a look at C2A, I'm sure you get the gist here. That should be our, little bit of a happy accident there, some Bob Ross moments. Look, a .0.bin isn't going to give us anything interesting, and that was the one that I was a little bit curious about. How does that differ from our .1.bin at the end there? Nothing peculiar in that, but what if I were to remove that .digit value and we just had the GUID that we were looking at previously? Did that have any sweet data for us? Yeah, okay, so this is the value. This is all the text that was present in my etc. hosts file. Again, that includes the path for the file that was open and some nonsense in the data. But don't forget, I never even saved this please subscribe file. I could make any changes to it, and I will not even modify or click save on file here. I won't hit Control S on my keyboard, but if I go navigate back and try to use this command line tool to see what was that 0FF value for that cached file, that has some other oddball data that I'm not too sure what it is. But look, what if I were to close out of Notepad again with that buffer not saved? Will that still make any changes here? Oh yeah, okay, cool. So we'll track that down, but Notepad was closed there. Maybe it just flushed whatever data that would have been present. Again, obviously opening up Notepad will bring that buffer right back to us. So that means that Windows Notepad, again, native, built-in, natural, maybe just like a knee-jerk reaction when you just want to slap and save some data, I don't know, moving fast on your computer, that will actually be cached and potentially an artifact that might be able to be used in DFIR or red teaming, pen testing, anything that you might think of. We could extract some of that data out with just simple strings like you saw, but what about that weird random data that was in the mix? Now, I was super interested in this. Again, I'm nerd sniped, so I want to go do some Googling, do some research, and see what the heck is this file all about? What's it made up of? What's the structure? What's the format? And are there any other tools that might be able to get that info out in a natural programmatic way? And I gotta be honest, I couldn't track down much of anything, right? If I were to look for Windows 11 Notepad tab state cache or whatever, can I find any of those details? If I Google this, looks like there's some chatter on Reddit. Delete Notepad cache, open content from previous thing. Are there other things that might be present here? Autosave functionality, right? Sysadmin is interesting. Maybe there's some good details there as to the file structure or what's even included there. Oh, this is cool. This is the commentary is like, look, this is maybe a minor thing to be annoyed about, but it caches anything that's in your last session. I know this might be kind of cheesy, but it's problematic because look, anyone could just jot down passwords or credit card information or anything, and even if they don't save the file, it'll still be preserved. We can dig into this. Hey, maybe there's some other settings we could play with, but there's no sweet detail as to what that bin file is made up of. Let me take a look at some of the other Google results here. How to delete that cache. I wonder if they mentioned the path. They weren't able to find it in that Reddit post, so let me see if there's any details here. They're looking for it. They say, where is that cache? Well, now you know. And 11 replies. Is there anything else in here? Oh, it might just be boilerplate Microsoft stuff. Yeah, okay. They're just running in circles, troubleshooting, falling down the rabbit hole. Oh, hey, someone mentioned it. Excellent. They tracked down the path. This is December. It's kind of recent. Here are some forum posts chatting about it, again, discussing the path. Ooh, we could dig into Windows state. I'm curious about that just as well. Everyone's chatting about the location, but not how we might be able to pull out data from that file other than just strings. Like, are there any DFIR tools? Like, if I add GitHub to this search, will it find anything interesting? I don't think so. I gotta be honest, I haven't found anything that would work with these bin files. So what I would like to do for this video is try to make some sense of the binary contents, the real data values represented in that .bin file, and see if we could write some code to maybe cut that up and pull out pertinent information that would be useful to us, again, as a blue teamer, as a red teamer, pen tester, ethical hacker, or digital forensics and incident responder. But before we dive into that, if I may say, look, I try my best with videos just like these, trying to get them out every single day, always showcasing a cool demo, sharing free education. The way that I'm able to do that as frequently as I do, and honestly the only way with free education, is with some sponsorship. I hope you're understanding of that, but please let me tell you about PlexTrack. Here's a question for you. Are you feeling the pain of pen test management and reporting? Trying to juggle data from multiple sources, collaborate on findings, or write a pen test report? All this takes time away from hacking and ultimately remediation. There has to be a better way. With PlexTrack, you can go beyond penetration testing management and reporting. PlexTrack helps you analyze your attack surface at the asset level, action all pen test and vulnerability scanner data in one place, use context-based scoring to prioritize risk, and finally, conquer the last mile of continuous validation. So hey, what does that mean for you? Faster pen test reporting time, better collaboration across teams and with stakeholders, the ability to address high-impact findings faster and more effectively, and proof of risk reduction. As Evan Pena, the consulting leader at Mandiant, said, PlexTrack enables our services team to deliver better reports in less time. Seriously, check out PlexTrack. I have great colleagues who use PlexTrack every day to manage their pen tests, and they're cutting reporting time in half. You can use my link below to learn more and get a personalized demo so you can start reporting less and hacking more. Huge thanks to PlexTrack for sponsoring this video. Alright, so because I mentioned I haven't been able to track down any documentation for the format and structure of this kind of file, we're going to need to dig into it just at the hex values, looking at the binary data. So we need a hex editor. I am going to be using 010 editor because I think it's phenomenal and I want to learn and do a whole lot more with it. So I have just installed the 010 editor, and we can open that up and see if we can make a little bit more sense out of the hexadecimal values that we saw in that local app data path. Let me get to packages. We'll get to that notepad folder that was in local state, tab state, and let's grab the full no.0 or .1 method there, and we'll open up .bin. So now we have this file open, and we can look through the first couple bytes to start this thing off. We can see what looks like, hey, probably our file path here. C users, John H, documents, screen connect diff.files. Yeah, so that's what I was working with as the file name, and we saw that in our strings output, but I'm curious about what makes up all these structures, what's in the bytes. Let me open up some of the other files just to kind of compare and contrast. We were looking at that 0f example, and that one just had our please subscribe data, but I immediately see a delta in the first couple bytes here. There's a difference where this NP, little maybe magic bytes, the header to denote this is that kind of bin file, presumably for Notepad, right? NP might be the start of this file, 00 at the null byte there, but a 1 that follows probably means this is a saved file, where the 0 probably means that that is a unsaved file. It's a buffer just floating in the ether, not written to disk. That's interesting to me because we have no file name included here, and when we're getting up to the contents that's included in that buffer, there's significantly less data than what is present in the one that is saved, right? Because of course, we'll have the full file path just as we saw, and then some nonsense that's up until the point where we get to our actual content. So at this point, we could try and experiment with this data and maybe write a tool that we're able to extract and parse out all the pertinent information and maybe do that en masse across all of the cached .bin files in that directory. Now, let me temper expectations here. This is an attempt. It's exploratory, it's discovery-based, I don't know, and I haven't finished this idea. Again, I don't know if any of these tools exist. I don't know if there's any documentation on the file structure that we're looking at here. If you know, please let me know in the comments because I'm fascinated by this, but maybe this is a cool exercise, maybe it's a cool activity, and maybe something that you want to try and do just as well. So I'm going to get back into Sublime Text, my text editor, and I'll open up a new file. And look, I know it would probably be really cool to write this in a compiled language. Be all hipster, do something in Golang or something in Rust or Nim or whatever. But for the exploratory sake, to prototype some stuff out, we could play and poke in Python, right? So let me do like a notepad parser.py. And look, we'll import the OS module so we could go ahead and check out our environment variable for our local app data. That will be our app data directory. And then the path that we want for all those files in there, right? Hopping back over to Windows Explorer, we could just grab this from the directory that we're in the address bar here. We could say the directory relative or whatever could just simply be this as a raw string. We'll paste that in, and then we could do some os.path.join for our app data directory and our relative directory location. Will that give us the full path here? I'll simply print this out just to sanity check. And I like to use format strings with an equal sign here so we could see that value displayed. Yep, that is looking good. Oh, but we aren't getting packages, actually. No, that isn't looking good. It's from exactly that. It's like we're starting from C packages that. That's a little gimmick and idiosyncrasy. Hey, when you're up against os path.join, it'll think this is an absolute path because of the / prefix there. So if I remove that, run this again, I'll hit Control B. That will give me the full path. And now I want to be able to actually glob for all those files. So let me glob. We'll import that and we'll do glob.glob on an os path.join of our full path with just an *bin. Let me look for any bin files there. And now can I display that list of bin files that we can store as a variable? List of bin files. Will that work here? Yeah, okay, so it'll extract all of those files out. Now I can do a for file name, or let's do a full file path in that list of bin files. And what we could do is just simply check if that full file path ends with a .0.bin, because remember, we didn't really care about those. Anything that started or ended with a 0.bin or a 1.bin, in which case we'll just go ahead and continue. So now I should only have the full file path where we have the full context there. Yep, just those bin files that we were working with previously. We could extract out the file name, just the like absolute path, or the base path, I think is the right wording there. That's path base name. That's the one for our full file path, and we'll print that out. Let me see, will that display just fine? Not really, no. Oh, we need our full file path variable. I passed the wrong one. There we go. Now we're getting just the GUID values. Looking good. So we can do a with open full file path. We'll read that as bytes here as a file pointer, or filp, I like to say. And we can say the contents will just be that read in. And I know this is bold here, but we could just honestly like print out the contents. But I will break this loop just for temporary in our testing to see the value come through. So spitting this all out, okay, now we have the contents, the raw binary and the hex values really representing the data in that format file here. Looks like this is the very, very first one, because remember that fourth byte that we saw was a 0 for an unsaved buffer. The others, when it had a 1 there, was like a written file. But we could actually extract out some of this data and make that kind of interesting, right? When we're working with these files here as we open them, we can say the magic bytes are the contents up to the, I guess, third byte there. That should print out if I just validate that super duper quick. Yeah, okay, that's the very start that we were seeing for these files. The next one was kind of a check here if it is a saved file or not. That would be the fourth value, correct? Is save file, that should be 0. No, okay, so I'm ahead by 1. That should be a 3. That is 0. And let's start to have at least some print statements for us to be able to play with. We will go ahead and print out the file name as we're kind of looking through each of these. Let's make that an F string again for the sake of our playground. And now that we could determine whether or not we're working with a saved file or an unsaved buffer, we could add some logic. Maybe we'll have to handle things differently, again, depending on how these all are structured, but that varies based off of whether or not that byte indicates it is a saved file or an unsaved buffer. This is where stuff might get weird and hairy, and I, again, haven't finished this all and don't exactly know because I can't track down document. Maybe I'm just making a fool of myself. Let's keep going. Let's focus on if it is a saved file, because in that case, we could extract out the file name, right? If it's a saved file, we'll do something, but if it's not a saved file, then we'll do something else. So again, let's just display this so we have our debug information. We can comment out later on if we want, but in that that case, we know that that is not a saved file. If it's not a saved file, and we won't break in this case, we'll comment that out. So we'll see that, ooh, okay, the data that we're working through, look, I only am going to care about these. Now, let's go look back at our 010 hex editor, because it looks like there's some data that follows on a byte representation of something. Well, no, okay, our C value is in there for the absolute path of the file location, right? And then the file name that we could carve out. Now, I'm curious because this selection that I have here, that file name kind of, hey, piece of data goes up to a 00B4 currently, and I don't see any other B4s in the mix. So let me just experiment with that for a moment to see if we could track down some of the pertinent information to help extract that out. Let me say that our contents from our, what is it? We start at this, which is the 5th value, I believe. If we slice that up to the point where we see the bytes of B4, I'll add the X denoting that, we might be able to see that full file name, correct? Just for the sake of carving it out. Or the problem is that errors, because that probably differs for the other cached binary data, but at least for our 639744 GUID, that will pull out the file name. Curious part here, though, is that this data, like if I were to actually kind of take a look at this, obviously we have a bunch of null bytes in the mix, separating each and every single character. So that's likely UTF-16. But if I were to get back to my terminal, and let me just open up Python for a quick second, we have this data that I can paste in as all that stuff we were just looking at. The length of that data is the length of our file name, right? Multiplied by 2 because of the serious amount of null bytes in between every single character. So we can divide that by 2, and that's 53. Okay, super duper cool. But looking back at our 010 editor, that we were missing after the 4 bytes that we start with, and then the 5th byte stuff starting our actual file name, there's one in between here, and that is hex 35. Now, if I go take a look back in Python, what is hex 35? It is, oh no, I did that backwards, right? It should be 0x35. I'm not taking the decimal value and bringing that to hex. I want to know literally 0x35 and its value. That should be 53. So that byte, what we would zero base index as the length of the file name, is present there in that 4th byte. Could we track that down? We could say length of file name, if it is a save file, remember, we'll drag that down, should actually be our contents on the 4th byte. Now, what I could do is display that super quick, again, just for our knowledge, but length of file name will go ahead and tell me that, look, we need our contents from the 5th character as we're starting that index, adding in the length of our file name times 2. Because that is, again, UTF-16 with null bytes in the mix. So I believe that should just be our original file name, right? From what was really genuinely opened up inside of Notepad for that cache file. Can I display that? Can I, now that I've smartly been able to track down that information, could I print out our original file name as we've extracted it? Yeah, perfect. Okay, so now that works smartly with not just our C3, 6, whatever, 639 GUID for the Screen Connect diff data, but also for our drivers, etc. hosts. But we will need to decode that as UTF-16. So our original file name could actually equal that value decoded as UTF-16, right? Will that work? Fingers crossed. Yeah, now we have our original file name that we can properly carve out. We should, you know what, actually try to break up this data. Let's multiply out a little divider here, and then let's wrap this in our F string to get the variable name included. How does that look? Cool. Now we can properly carve through and cut the file name out of all of those files. And let's actually move that print up, because it'd be sweet to do that for every single iteration. That way our 0 not saved file, when it's just an unsaved buffer, will still have the dividers in the mix. Whoa, did I do that wrong? Oh, it's not keeping track of the .0 or .1 bin files. So let me put that just before we work with the file name. That looks a little bit better. Cool. Okay, at this point, we've accomplished practically nothing. We can extract the file name, but the contents are the really interesting part here. And I think this is where stuff gets weird, because the structure that we were looking at, again, that random data between the file name and the contents, it might be variable depending on the file that we're looking at. I've seen this act and behave really strangely. And again, I'm waiting to hear if you've got any insights. Please do let me know in the comments. But if I pivot back to our 010 editor, we know that we're at least up to this location, right? We've got the file name carved out. But now, up until the point where we get to our data, there's this weird in-between from that B4 hex value up till our Screen Connect content start. Something that might be interesting though, if again, we know that we're looking at the length of some data, like we just saw for the file name, how long is the contents of the saved file that we wanted to work with? In this case, we have, okay, you can see it down below. Notepad is telling me about 1430 characters, but maybe that's not a good test. Maybe we should kind of, hey, have a clean slate to at least experiment with this in our own, again, exploratory setup here. So let me create a new file. We'll just call this, I don't know, anything.txt. I don't care. And we could say literally anything as the contents. Let me move to our tab state here. Looks like that is a new file, bd32. Let's remove all the others. And, oh yeah, okay, they're open in Notepad. So if we try to move on, it'll error because these are, again, the cache files. Let's close out Notepad and then try again on all of that. Let's make sure we can remove everything other than that BD321 that we wanted to play with. I'll move back to Sublime Text and I'll try to run this now. There. We can see our anything.txt is properly being read in. 010 is going to start whining because, hey, now it doesn't know where those are. But if I actually open up our BD file, we've got a smaller sample set to try to make sense of, right? Remember, we were trying to read up to like hex B4 for a second, but that structure is gone. And now we're getting some other weird things in between the file name and the contents, and it varies. It's completely different. I don't know if that's a timestamp or some file metadata like NTFS file system properties and attributes. It's seemingly random every single time that I look, but you might have a different experience. Please, I hope you try out this example and this exercise too. But we can try some deductive reasoning here, kind of as I was alluding to. This anything.txt with the contents literally anything is 17 characters long right now. Now, when we were experimenting just a bit ago, what is 17 in hex? And can we see that value, hex 11, anywhere inside of our contents, the bytes and the data here? I'll move back into our 010 editor. Do we have hex 11? Well, I see it there. Again, immediately following after our file name. So that's worthwhile and interesting, but I'm curious what happens if I expand that. Like, can I paste literally anything over and over and over again? What happens with that? Okay, 010 wants to reload it, so good. It is now going to do that. The total length of our file now is about 215 characters. So checking again in Python, 215 in hex is hex D7. Can I find hex D7 just after our file name? Yes, I can. You can see it right there. So that works, but now it has a 01 at the end of it. Presumably a 05 would follow every single time, but I don't know what this is going to do if we move past the 255 like bounds for a regular byte, right? Hex FF. If I paste my literally anything sample over and over and over again, now we've got 864 characters. What is that going to look like if it's in bytes? Let's reload in 010. End of our file name here, we have E006 up to 05. What is that? If I do E0, that's 224, which doesn't make sense. It's not filled up to like hex FF 255. Multiply that by hex 06. That's 1344, so it's close to the full length that we're seeing. Kind of. That is not super duper clear to me, but I think again, if we kind of look back at 010, we might be able to get a little bit clever, because I noticed, and maybe you were tracking this down just as well, when we get to the end of our file name, we get to presumably some length or something that matters some way, somehow, maybe not exactly the full length of the file contents, but it has a 05 and 01 delimiter, and that seems constant. If we go look for the start of our content, just before it is E06, and E06, which again is just what we saw for presumably some delimiter before our 05, and a 010000, many things there. If I toggle this and try to modify our file contents again here, I'll just delete some portions that still has, I don't know, some data. Oh, now we're at 420 characters. Nice, I like that a lot. We'll reload this. Looking at the structure again, we have A40305, and getting back to the start of our content, we have A403, and then some slight variation of A303. Oh man. So it's still not super reliable, but the 010000 and then that length value is something that we could use to denote the start of the content. And the content will run and continue all the way down until the end of our sum data and some trailing data that varies every single time. Now, I don't know if that's some CRC or checksum or something, but if I manipulate this, I don't even think I have to like modify the contents. If I resave the file, just, hey, create a space, delete the spaces, save the file, we'll see this will change and I'll have a new value there at the end. That's always seemingly 6 bytes. So I think we can get smart on this for a saved file. If we go back to our Python code, we'll go ahead and take from the original file start value, which we could probably save as a value. File name ending can be that math that we'll go ahead and use as our file name math ending value there. Starting from there, if we take the contents from our file name ending sliced up to our contents. Actually, we should use that as sort of the starting point to then find the index of our hex 05, right? We can make that a delimiter offset, I suppose. This is still super weird. In which case, the special delimiter could be the contents from the file name ending up to that delimiter offset. And we'll print out our special delimiter, see if we can get the value for that. Oh, great, nothing. Okay, so I must have mistaken that. Do we have a delimiter offset that is properly working? This is still dumb. This is why you should have like an actual file structure and not try to script it in Python, but I'm not smart. Okay, delimiter offset is 2. Oh, so we need to add that from our file name ending, right? Because we're slicing here. So we'll add a plus to that so we get to the values. Now our special delimiter is hex A403. That's what we're looking for. So that special delimiter will at least help us speed run through that chunk of data in between the file contents and the file name that we don't really know what it's doing, or if there's a timestamp, or if there's any unique special data in there. But again, every time I save the file, look, I'll add another space, again, save this data, reload this. Has that changed? Did that change? Let me add a space. Oh yeah, because we needed that for the 420. Always looking out for the 420. Reload. That value differs, but the D4 shenanigans in the mix, that is not what it used to be. Save again, reload. Yeah, now it's F4, whatever. So that does vary, and I'm not quite sure how. But we can use that special value before 05 to at least reliably build out the start of the file contents. So the delimiter offset and the special delimiter, we don't really need to display, but we could use our contents from the index of, these has to be byte strings here for our, oh, I want to use an F string so I could put our special delimiter in the mix, but I can't mix the bytes and an F string together. So we'll use a format string with %S in that case. A little bit weird, right? But I think that'll work. And then what would be hex 01, hex 00, hex 00, and another hex 00. And then once again, our special delimiter that will format in with our percent sign to slap in our special delimiter up to slicing to -6, right? Because we don't care about the last couple of values that aren't relative to our real data. Oh no, the space is that hex 20 is something that we do want. So I think it's only, how much is that? 4 characters, 5 characters? I think 4 at the very end, because the 00 might denote the end of the file, but UTF-16 will need the 0 following the space. So I'm getting in my own head and not making a whole lot of sense of this, but I hope now you kind of understand just as well where this gets a little bit weird. So let me use that 04 at the end to define this as file contents, or our original file contents, right? Does that work? Can I print this out as our original file contents displayed on the screen? Control B to run this. Seemingly that worked. Getting to the very top of this, we start with, oh, hang on, our A40301 and all that stuff is still in the mix. So we'll have to add that out, or make sure that we add the length of our special string. Oh gosh, what can we call that? What name should that have? Like an egg for egg hunter stuff when we're trying to find how that kicks off? We can cut that value and then call that, I don't know, start of file contents. And that's kind of the offset there. But if we look for that, we'll get the index of that start of file contents and add that in to where we start slicing from start of file contents. My goodness, this is confusing to say out loud. And I think we'll go to -5 now, presumably. So can I run this? No, I broke stuff. Oh, you're right. That is literal bytes, and we need to get the length of that. So let me change this to len, adding that on. Super weird. This is messy. This is dumb. If you write this in Rust or whatever, I'm sure it's better. But now we have this. And that is our file contents in UTF-16. So I could then do original file contents equals original file contents dot decode UTF-16, or just put that at the end of the line above. But this is already messy and gross as it is. Oh, and I wrote UTF-8 here. No, I'm an idiot. That should be UTF-16. Run this, and that is our data. Literally anything. But is that reliable? That's my next question. Like if I change this to, hello, I am John. And now I run this script. Hello, I am John. Okay, cool. What if I add a new line and then run that code? Oh no, something's already broken. Why? What is different about that? Let's go back to 010 editor, reload. Hello, I am John. The error was that it couldn't find the subsection. So we cut out our ending that we don't exactly care about. But when we get to our file name as our anchor, the length that we see 11 up to 05, do we find another 11 just before our contents? We see a 10. Why? We still see the same 01000 just before all the actual values. But what makes that different? Why did that change? What if I add another new line? I just hit enter here, reload in 010. Now we have the length of 13. What? But just before our contents is 11. Is that something we can use as an indicator? Like the 0001 and then some static value that is, or some same value between the 0100. This is dumb. Added another new line just to test it. Now it's 15 and then 12, 12, 010, 0012. Maybe that's reliable. Maybe the same value and then the 01000 and then that same value. Maybe that is a good way to start. What if I just copy paste, add a bunch of these, bring me past hex FF or 255 characters in length. If I reload again, that gives me E802. And before that, our 010 mex. And then the same value set up to that. I so wish there were documentation. But we could, if we were getting stupid and scrappy, use that as our anchor. Because I don't see any 0001 in that strange structure after the file name. So what we could do is change this to determine a different special delimiter where we're not looking for what would come before 05 anymore, because that is seemingly unreliable, but instead we look for the 01 and then the text that is duplicated after, right? So let's change our delimiter offset to not look for 005, but look for hex 0100. Can we get that? And let's clear out all that other stuff that we don't need to see quite yet. Do we see this? Yes, we do. So from the delimiter offset, we slice from the delimiter offset. Actually, we could call that like a delimiter start, right? And then a delimiter end. That would be our 010000. We'll add that in, validate that we can determine the start and end, which should give us 4 bytes ultimately, right? No, oh shoot. Yeah, we have to move from that location. So it would have to be plus our delimiter start, right? No, again. Do we have to add 1 to that so we can keep like moving forward? No. Oh no, we have to add the length of the delimiter start, of what we were searching for. So it has to be 2 or 3 to get ahead of it. No. Dang it. Oh, wait a second. I have that backwards. It should be 0001. That's the problem. And we don't even need all that. So cutting from there we go. Start is 45, end is 51. That will give us 6 bytes, which ultimately means those will cut out the start delimiter marker, and that'll give us 4, and we'll determine what those bytes actually are. Yeah? So we'll get file marker to equal our contents from our file name ending, and we can actually add these. Right, let's do that ahead of it, so that way our delimiter start will actually have be sort of baselined after the file name ending. Same thing with the delimiter end. And that way we'll be able to extract out the file marker from our delimiter start plus 2, referring to the length of what we're looking for to find that delimiter, up to our delimiter end. And that will give us the file marker that we're ultimately looking for, that EB or E0 thing, right? E8, that's the one. So now we cut that in half and we say the file marker is really going to equal the file marker up to the length of the file marker cut in half. Now our file marker, oh yeah, sorry, no, divide by 2 outside of len. Now our file marker, okay. String indexes must be integers. Yeah, just make it an integer. Use the integer division, 2 dividing signs. Now we have E802, which is the safe and sane, so far as I can tell, real world delimiter that we could use from our contents, given delimiter end plus 4, which is the length of what we were looking for to start with. Actually, no, we don't even need that. I think we can make that a variable first to start with. So start of file contents should equal our delimiter end plus the 4 values, and we should define this as a variable as like, hey, what we're searching for to find that. Plus, oh no, we'll just need to index that, I think. That's probably the smarter way to do that. So we'll say the contents from that location index to our file marker will give us the start of file context value that we're looking for. No. Unless, well, no, it is right after it. So that is correct. So that using a delimiter versus an offset versus indexing and trying to hunt it down really doesn't matter. We just add on. Is that like a static number length every single time? Am I just, again, making this more and more complicated for myself? I don't think so. If we add the length of the file marker, we could just use that as file contents on its own. Like up to -5 is what we used to cut the ending. Was that right? Yeah, -5. I feel like I've just overcomplicated that and solved nothing. So let me try to display the file contents now. And that works. Sure. Again, we'll decode that. We'll make these original file contents. Steal that line back over there. But I'm not sure that's solved for anything. Like, I could try to print this out now reliably with what the actual contents are. But if I tweak this, again, say anything to start, we'll run that. That validates it found it. If I add more to this, run it again, that works. Let me add a new line, run it again, that works. Another new line, still works. Okay, maybe I'm not crazy. Am I just getting like too far inside my own head? Let me add another character, another, and another. I'm seeing that reliably work. I'm seeing that be able to track down the contents. And this should work thanks to the way that we wrote our script, because we're globbing through all the files for any of the tabs that are open inside of Notepad and the files that exist here. So I think we're like looking good in a scrappy, dumb way to carve that out. But I totally acknowledge that we haven't even touched things that aren't a saved file and things that are just a unsaved buffer. The only sticking point that I have with that, like, is if I were to go, hey, again, back into Notepad, let's do our hello, my name is John. I could open up a new created tab buffer. It is completely different, and in some cases doesn't even have the content staged until I close out of the Notepad instance. Let me see if that will work. I'll close out here, reload. Now we see the contents, but because there's no file name to extract out, it just immediately gets into some content somewhere. Okay, probably based off the length that we could use to track that down. That could work. And again, subtracting 5 random values. We could write that and maybe that would be reliable, but what if I open up Notepad again and made changes, adding content? How does that look in 010 editor? Okay, none of that is present, really. So again, I'd need to close out Notepad, reload that, see it in action. But let me up the ante because again, this is an unsaved buffer. So I could say if I were to delete some content, doing something new, if I reload this, it actually adds onto it. And I'll, again, probably close this while I reload that. Okay, that will see it in action. That's fine. But remember, this is only in the case where it is less than 255 characters in length, as that can be stored in 1 byte. So if I open up Notepad, add a new line, expand this to a boatload of data, close it out, what does this look like now? That's not bad. Okay, maybe we could write that. Maybe it is pretty reliable. As long as Notepad is closed, we could still probably extract out data. And if I just delete something and cut it, chunk it, what the size would have been there, reloading this, not closing Notepad yet. What did it do? Did it do anything? Close out Notepad. It reloads. Significantly less data. And that probably works fine. So we could script that just as well. The start of our content should follow based on a length, again, sort of like a magic or special delimiter that will be the same length as other bytes added to in between a 001 and a 0100, D00B. Would that work? Just the way that we have it? Like even without a file name kind of to start with? I think that might just behave. I'm trying to think about the edge cases. Where would that go wrong? Let me make another giant file where I just copy and paste all of this. All right, now we're at like, 20,000 characters. Close this Notepad, reload. The data that we're up against is EEA2, and that is what we would be looking for with the 01 up to the start of our data. Oh no, it is exactly that again. So we could check and validate that that data is all the same of what we're looking for, but ultimately that could still carve out the value. Sorry, I'm like making sense of this in my mind, trying to understand this. Again, driving in the dark without documentation to figure out real structure. But I almost feel like that same logic would work if there is no file name. Like what we did just a moment ago with 001 and 1000. I feel like it would work. So if it's not a saved file name ending or where we kind of continue off of would just be 5, right? Oh no, just probably from the start of the file itself. So let me toggle that logic, move this down, and if it's not a saved file, then we'll just say the file name ending. That like offset doesn't even matter and it could just be 0. Will that work? We've got our anything from our anything.txt file. And then the unsafe buffer is actually being processed. Totally fine. Holy cow. That's so dumb. Let me open up Notepad. And let me modify Scrappy Notes in the moment. Let me say, oh, bank password is super I love apple pie. Yeah? Don't save it. I'm not hitting Control S on my keyboard or hitting the menu to save it. But if I close out of Notepad, 010 should be able to see that data. And so should our Scrappy Dumbo tool for even the saved file and the unsaved file. Windows 11 Notepad is literally going to snitch on you for whatever you don't save in the text editor. Now, okay, look, I know that I just fell down the rabbit hole there publicly, and you could just do all this with stupid strings, but that's, you know, it's not as cool and as clean as something that we could build into our own tool. And maybe we could make this a little bit more fleshed out, a little bit more polished in Python or Rust or Golang. And yeah, you could use it like real structures and actually carve and process the file. Hey, super quick, John from the future here. Sorry to interrupt, but look, I did want to say I've been trying to tinker and play with this a little bit more, and it is still finicky. It might not work in all situations, but I want to get some other folks' input on this. And I asked my editor, Nordgaren, and he is much smarter than me, and he started to try and tackle this project in Rust. Let me make it clear, it is still early in development, and I think he's still running into the same walls that I have been in this video, finding weird idiosyncrasies and just odd behavior, especially for unsaved buffers. But if you'd like, you can find it. He put it online so far in Nordgaren on GitHub. Tab State Util is the name of the project. And again, literally only hours of work into this so far, and they put a note, look, this is still in early development. We're just still figuring it out. Does it work? Lol, KEKW. Hey, your mileage may vary. I appreciate some of the kudos here, and you could look through the README and the code if you would like, but ultimately, if really you're up for it, we'd love to crowdsource some of the intelligence, some of the info. Is there documentation for this? Have you seen any other tools that do this? There is still work to kind of figure out. But look, it is now in Rust if you wanted to dig into that code base. It's a little bit more structure, has a bit more context, and a little bit beefier, stronger, and sturdy than, again, my like shooting from the hip Python code. If you look into his code, though, just as well, you'll find a couple of the sweet little Easter eggs where, again, we're just trying to make sense of this. Let me be clear that the copy that I completed, in air quotes, to show in this video did not handle or work with any of those unsaved buffers when Notepad was still open. We always had to close the file to be able to reliably get data out of it. He has started to dig into some of those unsaved buffers when Notepad isn't writing that to disk or if it's closed out of the application. So, again, more stuff that you might be interested in digging into, and please, 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 we'd love all your input. Okay, that was just my quick interjection. I didn't want to interrupt. I'll let you get back to wrap up the video. But I thought, hey, this scrappy exploratory thing was still kind of fun. And if some way, somehow, you were able to make sense of it and follow along with me, hey, kudos, hats off to you all. But I think this might be some cool tooling to, again, seriously use for DFIR, digital forensics incident response, or red teaming, penetration testing, and ethical hacking. And I don't know of any tools that do this out on the internet yet. So that, I hope, is a cool thing to showcase in a video. Thank you so much for watching. I hope you enjoyed this video. And if you did, please do all those YouTube algorithm things. And especially, please give some love to our sponsor, PlexTrack. Link in the video description. And hey, for your next pen test, hey, maybe you can use a tool just like this, and you'll use PlexTrack to crank out the report lightning fast. I'll see you in the next video.